Now, in chapter 1, we're going to look at our electronic breadboard. That is this little breadboard right here. Now, if you've done the basic electronics course, you'll remember that we used a snack board which was a lot bigger. It looked something like this. We used this snack board. Now, this snack board had 5 columns, 1, 2, 3, 4, 5, and it had 4 holes, 1, 2, 3, 4. Not quite holes, but 4 little screws that we would actually build circuits on. Now, this little breadboard is actually very similar to our snack board. It also has 5 columns, 1, 2, 3, 4, 5, but instead of 4 holes, it has 5 holes running down like that. So in the same way we used our snack board to create circuits, we are going to use our little electronic breadboard. Now, what's nice about the snack board is you can physically see the current, or not the current, but where the current will flow through the copper tapes. But unfortunately, with the little breadboard, we won't really see that. We just see the plastic outer cover of it. But inside each one of them is a little metal strip that allows that whole column to be connected. Okay, so let's look at our little electronic breadboard. Notice that there are numbers 1, 2, 3 just there in the middle, just as a bit of a reference. So if you want to, you could think of it as 0, 1, 2, 3, 4. Okay, now when connecting our batteries to our electronic breadboard, there are 2 ways. The one is correct, the one is very incorrect. The incorrect way is to connect it in the same column. So that's by putting the positive in, let's say, column 0, and you put the negative in that same column. That will create what we call a short circuit. And I have seen many little breadboards melting because of short circuits, or even battery packs melting and unable to be switched off, and so on and so forth. So it's really dangerous to melt your boards and things like that through short circuits. So please be wary of a short circuit. So the correct way of doing it would be to put your positive in one column and the negative in a other column. In that way it is safe, and each column is then filled with either positive or negative. Let's connect our bright LED to test this circuit. Now you'll notice on page 3 at the bottom that the first circuit we're going to be doing has a little picture of a battery pack in it, okay, which means negative is on the left there, and then positive is on the right, column right next to it there. So column 0 will be our negative, and column 1 will be our positive. And then the bright LED has a long leg, which is positive, and a short leg, which is negative. Also notice that on your bright LED, there's a flat side there that also shows our negative. So let's quickly put the positive by positive and negative by negative, and there we go. Our bright LED is shining. That's amazing. Now, your battery pack has got a little lever, which if you disconnect it, then the current does not flow through our batteries anymore. And if you remember from basic electronics, this is a 3-volt battery pack because these batteries are connected in series. So let's close this down, and then you'll see that the light comes on. Light comes on, and that's exactly what we want. Notice though that in your diagrams in the book, we're not going to show a battery pack every time. Instead, we're going to say 3 volt, and then that just is the reference for our battery pack. Okay, let's move over to the next activity. What we're going to be doing now is we're going to create a little circuit with a resistor. Now we're going to take out our bright LED. We are going to move our positive to the further side, which would be column 4. And then we're going to use our red LED, and we're going to put the negative lead by the negative and then the positive lead on column 1, something like that. Now notice that the resistor might have little paper on it. This was just to keep them separate while they were in a big strand together. So it does not affect the circuit, you can just pull them off. Now a resistor has no polarity, it's not sensitive like an LED, so you can put it either way around. So what we want to do is we want to connect the positive to the LED, but we want the current to flow through the resistor so that the resistor can limit the amount of current going to, or reduce the amount of current going to the LED. So let's put that in place right over there, connected to the positive, right over there, connected to the LED, and let's switch on our battery pack. And there we go, our second circuit on our little mini breadboard. Okay, the next one is very simple. We're going to be creating a little switch. So let's unplug this, and we're going to go back to our bright LED with a switch. Okay, let's take that out. Let's put in our switch. Now notice our switch is quite small, but it fits quite nicely into our breadboard. It's designed to squeeze right in there. We're going to put it in the second row from the bottom, and we're going to put it on column 1, 2, and 3. Right over there. Okay, now the positive we're going to be connecting into the middle, which we call the pole. So this will be the single pole. Now if you notice carefully, if you look carefully at our little switch, we have got a pole and we have got 2 throws. So what we call this is we call it a single pole and a double throw. So that means if I switch the switch to this side, these 2 legs are connected. If I switch it to the left side, then the middle and the left are connected. So the pole will always be connected, and it will either throw the current to the right side or throw it to the left side. So bearing that in mind, we are going to connect our positive wire to the actual pole of our switch, which will be the middle leg. So we've got negative on the side there, not touching anything, and we've got positive going to the middle leg of our switch. Now we're going to connect our bright LED. Now the question comes though, where do we connect this? If you look carefully, we're going to connect the negative side into column 0 and the positive side into column 1. But nothing's happening. The batteries are on, but nothing's happening. The reason for this is the switch is towards the right. We need to switch it towards the left so that the pole can throw the positive current to that left leg. Let's see what happens. There the light comes on. Now we've created a little switch to be able to switch on and off our little LED. Okay, but this SPDT, single pole double throw little switch, has got 2 throws. That means we can add another component. Okay, let's see. So if we wanted to add a buzzer, and we would put the buzzer's positive leg on this side, that means that when the switch is towards the right, it's going to give power through to the buzzer. We need to connect it somehow to the negative. Now we could connect it directly to the negative like that, or we could use a little male to male little wire, and we can bridge that negative. We can take it over to that side and put it in that open hole there, and therefore the buzzer can just be connected next to itself right over there. So when I switch it the other way, the light will shine. And when I switch it that way, the buzzer will sound. Light will shine. Now the reason for this is I've got a pole, and in my pole there is a positive. But on my left throw, there is a bright LED connected to it. And on my right throw, there is a buzzer connected to it. Now I want you to take a moment. I want you to have fun with your little switch. Maybe let it put on 2 different lights. Have a little bit of fun and see if you can create a few nice circuits with your new little switch that you've got. Once you've done that, then it's time to do your self-test. Okay, so now it's time for our self-test. The purpose of these little tests is not to catch you out or to make life difficult for you. It's actually to help you remember important little facts of the chapter. Now, self-test 1 is all about the first chapter that you did. So the first question is, how many connected columns are there on the mini electronic breadboard? Now let me just switch this off. How many columns are there? Write it down. Okay, true or false? Second question. Always connect both leads of the batteries in the same column. True or false? Number 3, yes or no, will the following circuit switch the LED on? Now have a close look at that circuit. Look carefully at the pole and the throw of the switch, and you give the answer. Will it put the LED on? Yes or no? And then the last question, how many holes will an electronic breadboard have if it had 10 columns of 5 holes? You can do a little bit of math there and just give us the answer. Now we have a character tip. The character tip is just all about what we've learned in electronics and learned with the little circuits we've been playing around, and how can we take that and apply it to our lives, to our families, to our relationships. So the first little character tip we have is, just like the electronic breadboard is very helpful to build circuits on, we need to help the people around us, like our parents, our teachers, and other students. True leadership is seen in deeds that help and serve others, not just telling others what to do, but through actually serving them and helping them. We can be leaders as well. Go out and change your community and serve your community. See you in the next chapter.